Hey class, welcome to lesson 6.6, which is all about organizing data using matrices. By the end of this lesson, you should be able to organize data in matrices as well as be able to perform matrix operations. So first, let's talk about what are some of these new words. A matrix is a rectangular arrangement of numbers in rows and columns. So basically, it looks something like this, where I have different numbers and they are presented in something like this. So an element is any number in a matrix. So 11 is an example of an element in this matrix. Dimensions is the number of rows and columns in the matrix. So if you look at the one that I just drew, I have one row, two rows. So you do row, and then you draw a little X, kind of like that. It means by or multiplication. And then your columns, your number of columns. So I have column 2, and column 3. So for this matrix, it's a 2 for the rows by 3. That's how I would write the dimensions for that. A scalar is any number you decide to multiply a matrix by. It's always a constant number. So if I say that this matrix is named A, so matrix A, and I say, tell me what is 3A. That means you go and you multiply every number inside that matrix by 3. Okay, and that is, but 3 is the scalar, and I just described what scalar multiplication is. Okay, so let's look first. We want to state the dimensions of each matrix and then identify the position of the circled element in each matrix. So I have 2 rows and 2 columns. So my dimensions for this matrix is a 2 by 2, and the position of the circled element is row 1, column 2. So that's all I have to do in order to identify where the position is of that circled element. Here I have 3 rows, so it's going to be a 3 by, and then I have 5 columns. So it's a 3 by 5 matrix, and the position of the circled element is the 3rd row, so row 3, column 4. Okay. Hopefully that's pretty straightforward, but if you have questions, please be sure to ask. All right, go ahead and try figuring this first one out on your own, see how you do. Hopefully you said the answer was 3 by 2 for the dimensions, and that the circled element is the 1st row, 2nd column. Okay? What if I give you a table and I say, describe the table a little bit. At a particular horseback riding competition, blue ribbons go to the highest score in an event. Use a matrix to organize the scores for each participant for each event. Which participant won the most blue ribbons? Okay, so this example might seem a little bit silly to you, but it's building a foundation that you're going to expand on a lot more in Algebra 2, okay? So what you do is basically start by making this table. We're going to take these numbers and we are going to transfer them over to our matrix. So we're going to have a jumping. So I'm just going to write that up there so I know which is which. A cutting and raining. So these are all the events at the horseback riding competition. And then we have the various participants. Okay, so now I just transfer these numbers over. So instead of being in a table format, it is in a matrix format. That's really all I have to do at first. But then I want to describe who ended up with the most blue ribbons. So I have to go through and determine how many blue ribbons did each participant end up with. So I do for Lukden 7 plus 8 plus 6. So I end up with 21. For Hamida, 10 plus 10 plus 8 gives me 28. For Mandy, 12 plus 9 plus 11 gives me 32. For Rosine, 11 plus 7 plus 10 gives me 28. So I know that Mandy is the overall blue ribbon winner. And that is what I would write. So when grading these, I would look for both the matrix and the answer to the question. Go ahead and take a look at this example and try it on your own. Hopefully you decided the matrix letter B was the correct answer for transferring it into a matrix instead of a table. If you have any questions, be sure to let me know. But let's take a look at example 3. So I'm given 3 matrices. Fun fact, singular is matrix, plural is matrices, okay? So I'm given 3 matrices, A, B, and C, and I want to find A plus B, and for letter B, I want to find A plus C. So first we're going to look at A plus B. The way that you do this is you look for the different elements in the matrices, and you find the one that it corresponds with in the other matrices. So I have a -8 and -12 in the 1, 1 position, row 1, column 1. So I take that -8 and I say -8 plus -12. So I'm left with -20 in that position for my new matrice. Then I say 15 plus 10, that gives me 25. 9 plus -13, I have a -4. 4 plus -8 gives me -4. -3 plus 11 is +8. 7 plus -6 is a +1. And that's my answer. That is the sum of those 2 matrices. Okay, letter B, matrix A plus matrix C. So I would do -8 plus -4, -15 plus 8, 9 plus 12, 4 plus, I don't have anything in matrix C in that same position. So notice that matrix C is 1 row by 3 columns, and matrix A is 2 rows by 3 columns. Since these two don't have the same dimension, you cannot add or subtract them. So all you have to write is, if you're asked to add matrices or subtract matrices that are not the same dimensions, you just have to write not possible. Okay? Go ahead and try this one on your own, see how you do. Hopefully you determine that this very first one here is not possible because we have a 2 by 2 matrix and a 2 by 3 matrix. And since those are not the same dimensions, you cannot do it. Go ahead and solve this problem as well. Hopefully the matrix you ended up with was 9, -2, 3, 8. If you have any questions about that, please be sure to ask. Let's look at example 4. We're doing basically the same thing, but instead of a sum, we're looking for a difference. So instead of adding, we're subtracting. So letter A, B minus C. I have a 2 by 2 and a 2 by 1. These are different size matrices, so I just have to say not possible. Easy enough. Now A minus B. So I go A first because it's listed first. So 8 minus a -1. 8 minus a -1 becomes 8 plus 1, or 9. Then we have 10 minus 12, so that's -2. And I have -3 minus 4, that's -7. Negative 8 minus the negative 2, negative 8 plus 2, because negative minus a negative. Or sorry, minus a negative. So negative 8 minus negative 2 becomes negative 8 plus 2. Made that much more complicated than it had to be. Sorry. So this would be my answer for that example. Go ahead and try to find this answer. Hopefully you determined the correct matrix was 0, 12, negative 2, negative 7. And go ahead and try this one on your own. Hopefully you realize this one was not possible because they are two different dimensions. Alright, our very last example has to do with that scalar multiplication. So I'm giving you a matrix letter A, and I want you to find 3A. So what that means is you multiply everything inside by a 3. You are distributing here. So what is 3 times 9? 27. 3 times negative 5 is negative 15. 3 times negative 3 is negative 9. 3 times negative 12 is negative 36. 3 times 4 is 12. 3 times 2, 6. And I just keep going until I finish multiplying everything inside that matrix by 3 to get my answer. Alright, go ahead and try to solve this last problem on your own and see how you do. Hopefully you ended up with 1480, negative 12, 410. If you have any questions about that, please be sure to ask for some help. Have a great day.